Hi, I am students. This video is the answers to the problems in the Day 4 packet for Outdoor Ed, and this is just another review for the test which will happen on Day 5. So if you are here this week in Day 4, I'll be available in SOAR for extra help, and if it's next week, Mr. Fitzpatrick will be available for extra help. So let's go ahead and look at the first problem. So let's read through this problem and then see what we can do with all these numbers. All right. Sam is going to a hockey game and he has paid $250 for the ticket. She plans to eat many hot dogs at $7 each and drink 3 sodas at $5 each. She only has $325 total, including the price of the ticket, to spend. How many hot dogs can she eat to stay under that $325? Alright, so we have a bunch of numbers here. We have $250 for the ticket. You have $7 for each hot dog, but we don't know how many hot dogs yet. 3 sodas that are $5 each, and a total of $325. So let's start out thinking how much she is definitely paying that we know. So I'm going to write something like this. Definitely paying. So definitely she's paying for the ticket, which is $250. And she's definitely drinking 3 sodas, and they're $5 each. So that's going to be $15. And again, I got that from 3 times 5. So definitely we know that we're paying $265. We don't know how much we're paying for the hot dogs yet, because we don't know how many hot dogs we're going to get. But we know we're limited in how much we can spend total. So let's write inequality to describe this situation. So we know that she's definitely paying $265. And we know we're going to add that to that $7 for each hot dog, which I will call H. So again, that each tells us we're multiplying 7 times the number of hot dogs, but our unknown is number of hot dogs. This will give us our total price, again the $265 plus $7 for each hot dog. But we know we have to keep it less than or equal to $325, because that's how much money she has. And it's equal to because we could spend potentially exactly $325 if possibly. So that's why we make it an equal to as well. Okay, another 2-step equation. So again, I circle the number and the letter to let me know that's what I do last. So I undo the 265 by subtraction, and do that on this side as well. And this becomes 0, which means it goes away, and I'm left with 7H. I bring down my inequality, and 325 minus 65, I believe, is 60, I think. And then we will divide both sides by 7 to undo this 7 times H. And this doesn't work out evenly, right? So we need to know how many times 7 goes into 60. I'm going to just do this quickly by hand. Let's see. 7 times 8 is 56. That leaves me 16. 10 minus 6 is 4. And then I'm going to add a 0. 7 times Must be 7 times 5 is 35. So 10 minus 5 is 5. Add another 0. 7 times 7 is 49. So this is going to go on and on. It's not going to come out evenly. So we're going to say roughly it's 8.57. Now, hot dogs don't come in fractions. You have to do it in whole. So we know from this that we can't buy 9 hot dogs because H has to be less than 8.57. So 9 is going to put us over. So what this really means is it has to be less than or equal to 8 hot dogs. Again, because we can't buy a fraction of a hot dog. So 8 will keep us under the 325, 9 will put us over, so we'll say the solution is 8 is less than or equal to 8 hot dogs. Alright, let's take a look at the next question. Alright, let's read this together. For which inequalities below will you at some point have to switch the direction of the inequality to find the correct solution? So we talked about this a couple of ways. We said that while solving, whenever you divide or multiply by a negative number, you have to switch the direction of the inequality. And another way to look at that is if the coefficient of the variable is negative, you also switch the inequality. But those two are really the same thing because if the coefficient is negative of the variable, that means you'll be dividing by that at some point to undo it, and you'll be dividing by a negative. So let's take a look at these. So here we have 5 minus 2x is greater than 11. So we'd undo the 5, no problem, but we're left with a negative 2x. We're going to have to divide by a negative 2 in order to undo this, and in that process we would have to switch this. Okay, so A is definitely one of them. I'm going to circle it. Alright, let's take a look at B. Minus 3m plus 8 greater than 20. Again, we'd have to undo the 8. And then we're left with a negative 3m. And again, we're going to have to divide by a negative 3 in order to undo this negative 3. In that process, we would have to change the inequality. So once again, B is another one we'd have to do that. For C, well, we have 2x minus 9. We undo the 9 with a plus 9. That's not going to do anything. And then we'd have to undo the 2. But the 2 is positive, so we'd be dividing by a positive 2. That will not change the inequality when we divide by positive 2. So C is not one of our options. D, this is a one-step equation. We just have to undo the 3, and we would be dividing by a positive 3 for that to happen. So that's not going to change the inequality. For E, we have a negative 7x plus 1. We'd have to undo the plus 1 with a minus 1. And we do that on this side. That's not going to have any effect, but we're going to be left with a negative 7x on this side after we do that. And we're going to have to divide by a negative 7 to undo this, so dividing by a negative 7 will change the direction, so definitely have to do E. And then for F, let's see, we have 8 minus 11x. Remember, this minus goes with the 11, not with the 8, so we'd have to undo this with a minus 8 on both sides. We're left with a negative 11x. To undo that, we'd have to divide by a negative 11. And of course, if we're dividing by a negative, we change the direction of the inequality. So this one also would change in the process. Alright, so A, B, E, and F. And again, let's notice what they have in common. We have a negative 2 by the x, we have a negative 3 with the m, we have a negative 7 with the x, and we have a negative 11 with the x. All those would lead to switching the inequality during the solution. And for these, we have a positive 2x and a positive 3x. So those would not lead to changing the direction of the inequality during the solution. Alright, so let's solve a couple of these. So these are A, B, and F from that question. These are two-step equations. So as usual, I circle the number and the letter together. That means I do that last. So the first thing I do is undo the 5, and I subtract 5 from both sides to do that. I'm left with a negative 2x, bring down my inequality, is greater than 6. Then I divide by negative 2 to undo that 2 times x. Divide by negative 2. But of course, because I'm dividing by a negative, I'm going to change the direction of the inequality. So I'm left with x. I switch this to a less than, and 6 divided by negative 2 is a negative 3, because we have a positive 6 and a negative 2. So there's only one negative involved, which means my answer will be negative. Okay, for B, it's similar, right? I'm going to circle my letter and my number that are together, which means I do that last. So I'm going to undo the 8 with a minus 8. Do that on both sides, of course. I'm left with negative 3m is greater than 12. I need to undo that negative 3 times m by dividing by negative 3. And those, of course, will cancel out, leaving me with m on this side. But because I divided by a negative number, I have to change the direction of the inequality. 12 divided by negative 3 is a negative 4. Again, when I divide a positive number by a negative number, my answer is negative. And finally, I'm going to circle my number and my letter together, which means I do that last. Need to undo that 8, and again, that negative goes with the 11, not with the 8. So I have to subtract 8 to undo that 8, and do that on this side as well. That leaves me with 22 on the left-hand side, and a negative 11x on the right-hand side. To undo that negative 11 times x, I need to divide both sides by negative 11. And again, because I'm dividing by a negative, I have to change the direction of the inequality. These cancel out, of course, so I'm left with x. And 22 divided by negative 11 is negative 2. Positive divided by a negative number will always give me a negative. All right, let's take a look at the next question. All right, so question 4 is all about applying some of the properties that we know and combining like terms. So we have some distributed property situations we have to take care of, and then once we do that, then we'll be able to combine our like terms. So let's do distributed property first. So I have this situation, 3 times 2x and 3 times a minus 1. So that's going to give me 6x minus 3. And then this next piece is also distributive as well. This is really a minus that has to be distributed to the x and to the 5. So that's going to give me minus x minus 5. And the last piece stays the same. So I just can't add all these together. I can only add like terms. This is really important. So I'm going to underline the pieces that I can combine. I can combine anything that involves an x, and I can combine all of the numbers together, which I'm circling. All right, so what does that give me? So I have a 6x, and I have a minus x and a minus 3x. Remember, there's an invisible 1 there. Let's put that in there just to help us out a little bit here. So 6 minus 1 is 5, minus 3 is 2. So that leaves me with 2x. And then when we look at just the numbers, I'm adding a minus 3 and a minus 5 and a plus 8. And let's see, minus 3 and minus 5 give me minus 8. Then minus 8 and a plus 8 gives me 0. So actually, I'm done. Because you're not going to write plus 0. You can, but normally you wouldn't. So the final answer is actually 2x. All right, so how do I know this is correct? Well, first of all, I applied properties that were allowed to apply and added like terms. So everything I did was appropriate steps to give me an equivalent expression. But another way to do this is to pick a value for x and substitute it in the original one and substitute it in the second one and see if you get the same answer. So let's keep this really simple. What if x were equal to 0? So in the original one, I'm going to have 3. I'm going to have 2 times 0 minus 1 minus 0 plus 5 minus 3 times 0 plus 8. All right, let's evaluate this. So 2 times 0, of course, is 0, and I have a minus 1, so that's going to be 3 times a negative 1 minus 0 plus 5 is 5 minus 3 times 0, well, that's 0, so I don't have to worry about that. That's gone. And I have plus 8. All right. So 3 times minus 1 is minus 3. Minus 5, I don't need the parentheses anymore, plus 8. And guess what that equals? That, of course, equals 0. Now, if I take a look at my simplified expression, my equivalent expression, if I plug in 0 for that, I have 2x, but then that's 2 times 0, and that equals 0. So we know that we have equivalent expressions when we put the same value for x in, and we get the same answer. So if you have to do that on the test, I think that would be a nice way to do that. Pick a value for x and substitute it into both versions and see if you get the same number. All right, let's take a look at the next question. All right, this says, use factoring to answer the following questions. So let's take a look at part A. A square has an area of 16y squared. Find the length of one side. Well, this sounds like a good time for a picture. I'm going to sketch a square. Not my best work, but it's fine. So, a square is special. All the sides are the same. So I need a length that when I multiply it by itself gives me 16y squared. So that's not too bad. The y squared part's easy, right? Because if part of my length contains a y, when I multiply y times y, I get the y squared. So now I need a number that when I multiply by itself, I get 16. And hopefully you will figure out that 4 is the correct answer to that. And remember what the definition of factoring is. It is rewriting an expression as the product of two things. So we can write 16y squared as 4y times 4y. And that becomes the length of each of our sides. Because it's a square, they have to be the same. So you can factor 16y squared into two identical factors of 4y, which make them each the length. All right, so part B is a little bit different. We have a rectangle, so let's sketch a rectangle. And this one's a little trickier because we really don't know much about the length and the width of this. But we're going to factor this as best we can. And remember, factoring again is writing something as the product of two pieces. And we're going to look for pulling out numbers and letters that are in common for each of these pieces. So I'm going to write this again down here. So we have x 8xyz minus 4xy plus 4x. So I'm looking for the largest number that goes into 8, 4, and 4. That's going to be 4. And then we look for something that each one of these has in common. So I see that there's an x and an x and an x, so that's good. I see y, but no y here, so that's not going to be able to be factored out. This one has a z, so I can't factor out the z, so I can pull out the x. Alright, so what's left? I need to be able to multiply this times 3 different pieces that give me each of these. So this one has to have a 2, because I need 4 times 2 is 8. And 4x times 2yz, when I put it all together, will give me the 8xyz that I need up here. Alright, here I have 4 times 1 is 4, so that's okay. I've taken the x out, so I just need a y here. So again, 4x times minus 1y will give me minus 4xy. And then the last piece, again, I have another 1, because I need 4 times 1 equals 4. I've taken the x out, so I don't need to put the x in here, because 4x times 1 is going to give me 4x. So I'm done. Remember, when you are factoring something that has multiple pieces like this, the part in the parentheses also has to have the same number of pieces. So this adds 3. When I factor something out, I need to have 3 pieces left over in the middle. So let's clean this up just a little bit. I'm going to have 4x times 2yz minus y, you don't really need to write the 1, plus 1. So one possible set of dimensions for this rectangle is 4x times 2yz minus y plus 1, because this could be the width and this could be the length, because that's how you find the area. You multiply the dimensions of the rectangle. So we've found 2 things that when multiplied together give us the area, so they could possibly be the dimensions. And we did that by trying to factor something out. Again, factoring is turning an expression into the product of 2 things. Alright, let's look at the last problem. Alright, this says what value of x will make the following equation true? That means solve the equation. So I have some things to deal with here. I have a distributive piece that I have to take care of, and then I see that I'm going to have variables on both sides, so that's another issue that I have to deal with. So let's do the distributing piece first. So I have to multiply the 3 times the x and the 3 times the minus 2. That's going to give me 3x minus 6. And nothing else changes, so I still have the plus 5, and I still have 5x minus 9. And you're always looking to combine things when you can, and I notice here that I have 2 numbers that I can put together into one. So a minus 6 and a plus 5 is going to be a minus 1. So I can put those together like that. I can't add the 3x in because they're not like terms. I can only add 3x to other pieces that have x in it. Alright, and the right-hand side hasn't changed. And now we have this situation where I have a variable on both sides. And our rule of thumb has generally been to undo the smaller of the 2. So 3 is smaller than 5. So I'm going to undo that so that I get all of the x's on the same side. And the way I do that is, because this is a positive 3x over here, this minus goes with the 1, I'm going to do a minus 3x. So I do a minus 3x on this side and a minus 3x on the right-hand side. Again, we only do it once on each side. So this piece goes away, because when you add a 3x to a minus 3x, you get 0. So we're not going to write that 0. That leaves us with a minus 1 on the left-hand side. 5x minus 3x is 2x. Remember, like 5 apples minus 3 apples is 2 apples, not just 2. And the minus 9 stays as is. So now I have a normal two-step equation. So I'm going to circle the number and the letter together, which means I undo that last. So I have to undo the 9. I do that on both sides by adding 9 to both sides. And let me just note that you don't undo the minus 1. You work on the side that has the variable on it, okay? Work on the side that has the variable on it. That's what you're undoing around. All right, so what does that give us? We have a minus 1 and a plus 9. That's going to give us a plus 8. And we just have the 2x left over here because the minus 9 and the plus 9 have become 0, so they go away. And then finally, we undo the 2 times x by dividing by 2, and that's going to give us 4, because these cancel each other out, and I'm left with x equals 4. And we're done. All right, so again, if you have any questions on these, I'm Mr. Rorson. I'm available in SOAR this week, the first full week of ODE, and then Mr. Fitzpatrick will be available next week in SOAR to help you with any questions you might have.